getting to telophase 2, and the reading says it. I know it's hard. It really is hard. It's a weird thing because you're like, wait a second. I remember when we went through metaphase, we just lined them all up. And the thing is, when we talked about this, you have your two homologs that pair up next to each other, and I helped you out with that. When you go through metaphase, all the double chromosomes line up in one single file line. So it doesn't really matter who's next, who's first. You're in one line. You're ultimately, this is a number 1, this is number 1, this is dad's, this is number 1, this is number 1, this is from mom, and they're all going to split up, and you're going to have two identical cells. It's going to work great. The kind of thing that I try and show with meiosis, stop, put all your pencils down, put all your pencils down. The thing that I show with meiosis is this. This is basically how it works up. If I said that each boy and girl represents like a homologous pair, and I said every guy get a girl and every girl get a guy, just line up and make a line, and you guys hold hands and make one big line, is it going to have all the girls on one side and all the boys on one side? No, by chance it's going to be a mixed bag. That's what happens when you go through meiosis. When you go through metaphase 1 of meiosis, that's where the trick is, and that's where the difference between mitosis and meiosis is. Because you can see when you have mitosis, they all line up in a line like this. Mitosis, or meiosis, sorry, the homologs pair up, but it's a random assortment of who goes where. And that's why I said flip the coin, and it's going to go, hey, wait a second, I'm going to go here or here, and mom's going to be over here. Watch this. I'm going to show you real quick. And you can do this, and I don't mind helping you guys out with this, because this is kind of difficult, and you still got a little bit more to go with this. And I took away some of the picture stuff, so I went straight with reading. So watch. We'll do the first cell. Watch. Give me one pencil. And most of you guys have a great start on this, and it's fine. So I'm going to draw my one pencil, my one cell, I mean. And the one thing I said back to these guys, I said, you guys are drawing X's. X's are fine, and I get it. But the sister chromatids are not crossed over like this. They're like this. You originally have the one chromosome, like we said, where you have this one chromosome. But after replication, you double it up, and you have two chromosomes that are now identical, that are attached to each other. So when you set up your homologs, we'll do it like this. Watch. We'll say, we'll use green. Can you guys see okay? We'll use green as number 1. We'll say this is number 1, and this is the homolog. This is number 2. I'll go slow. This is number 2, and that's the other homolog. Just put your pencils down right now so I can explain it. Believe me, I'll help you out. This is number 3. This is number 4. And I think I had number 5. This kind of good color is probably about the same. Number 5 is right here. Of course, it goes outside the cell. That's fine. Now watch. Who's got a coin? Okay. Go ahead and flip it. And so heads is dad on the left. Dad on left. So go ahead, Cole. Go ahead and flip it. Tails. Tails. So dad's on the right. So I'm gonna put this one's dad. This one's mom. Next one. Flip it. Heads. Heads again. Dad's on the right. Mom's chromosome's right here. Go ahead. Tails. Okay, so dad's now on this side. So this is dad's chromosome. It's, you get the idea. Keep going. Heads for the next one. Tails. Okay, heads. Whoopsie. Okay. Heads again. Do heads for the last one? Yeah. Okay, so watch. Let's do it this way. Let's say it was tails. Okay? And you had this random assortment. So when these guys ultimately split, watch, when they ultimately split, they're going to go through this metaphase 1 and then anaphase 1, where these guys are going to split down the middle right there. And watch. When this happens, you're going to split off. Stay with me. Stay with me. So we got this guy, this guy, this guy, this guy. Now at this point, what you've gone to is, since we have 2 new cells, this is, what phase? Does anybody know? Telophase what? Telophase 1. Good. And that's why it's a little bit different than mitosis. Now watch. Now the pairing ends up staying the same. So this one is dad's, this one is dad's, this one is mom's, this one is dad's, this one is mom's. On the other side, this one's mom's, this one's dad, this one is mom, this one is dad. Can we still see? This one's mom. Can we still see? Now watch. This is why the whole meiosis is goofy. Pencils down last time, please. Because this is where you start getting weird variations. You're making gametes, you're either making sperm or egg. These guys go through one more phase of anaphase. This is called anaphase 2. This is now basically moving straight into metaphase 1, 2, and ultimately you go through telophase 2. Now what ends up happening is you have a total of how many cells? 4 new cells that have how many chromosomes? They have half as many chromosomes. Half as many chromosomes. Okay? Because we said that chromosome just looks like that one thing like this. So I'm going to do it like this. Last one, squeezed in there. Of course it goes off. But when you look at these two, this is mom's, dad's, mom, dad, mom. Other side, this one's dad, this one's dad, this one's dad, this one's dad. This one is mom. This one is mom. Dad. Mom. So here's the thing. If you look at these two cells over to the left, these are identical to each other. These two cells on the right are identical cells. If these were our sperm cells, and let's say this is my sperm cell, and this is what I'm bringing to make my one kid, and then my wife brings her set. But I'm basically giving the chromosome, because originally I got my chromosomes from my mom and my dad. But when I went through the whole split and separation of everything, you got down here, what I'm giving to my kid is I'm giving the chromosome that I got from my mom, this number 2 that I got from my dad, the number 3 that I got from my mom, the number 4 that I got from my dad, and the number 4 that I got from my mom, 5 I mean. If I had used these 2 sperm cells, they would have been a different combination. That's how you get this weird variation between kids. And you're like, okay, I get it. Now that's why you have mom's eyes and I have dad's hair color, or so forth. But on average, you end up having an even amount. And if you, like I said at the beginning of class, when you look at your siblings and you're like, we don't look anything alike, you do have a lot of things in common. Probably have about half things on common on average, okay? So finish this up. Does it make sense? Okay, finish that thing up. You can go ahead and stop recording.